So this is the second of two videos looking at writing numbers in standard form. I've put a link to the first video in the description below. Now we started the previous video with a calculation, 50 million multiplied by 70 million. And on my smartphone it produced an answer like this, and on my scientific calculator it produced an answer like this. And these answers were basically given in standard form. And so to establish what they meant, we looked at writing numbers in standard form using the base 10 number grid. And here are the examples that we covered. And notice that the columns to our number grid, instead of being units, tens, hundreds, thousands, I wrote them down as powers of 10. 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, before the decimal point and after the decimal point, 10 to the power of minus 1, 10 to the power of minus 2, and so on. And we ended up with numbers written in standard form looking something like this, where this decimal is a number between 1 and 10, and it is multiplied by a power of 10. Looking at this in more detail, we had 504,000. We would look at the position of the 5, which was in the 10 to the power of 5 column, and then we would write the number as 5.04, where the 04 relates to these two digits, and we multiply this by 10 to the power of 5, which was the position of the digit 5 in our original number. And of course, what this means is 5.04 multiplied by 100,000. So we end up with 5.04 multiplied by 10 to the power of 5. And if we had 0.00049, the digit 4 was in the 10 to the power of minus 4 column. And so we end up with 4.9 multiplied by 10 to the power of minus 4, where this 9 is this digit here. And of course, what this means is 4.9 multiplied by 1 over 10,000, which is also equivalent to 4.9 divided by 10,000. So writing numbers in standard form is basically writing numbers as a multiplication, or in the case of negative powers, a division. And looking back at the original calculation and the answers that we got on our smartphone and scientific calculator, this meant 3.5 multiplied by 10 to the power of 15, which meant that the 3 was in the 10 to the power of 15 column, which would have meant the 5 would have been in the 10 to the power of 14 column. And so what standard form was doing was it was allowing us to write large numbers in a simpler way. The idea of introducing standard form using the base 10 number grid was to provide a visual way or a visual understanding of what's going on. But this approach isn't exactly practical, drawing out a grid every time to work out a number in standard form. So in this video, we're going to look at a more practical approach. We are going to use the examples that we used in the previous video. So here are 5 numbers. The first one, 250, has already been done. It's already in standard form. But let's look at this. 250 is equal to 2.5 multiplied by 10 to the power of 2. So let's write down 250. This 250 is going to be written as 2.5. Remember that this number is between 1 and 10. We're going to end up with a decimal point between the 2 and the 5. Well, think of this as our cutoff point. I'm then going to put a mark where the decimal point currently is in the number 250, which is basically after the 0. What I'm going to do now, you'll often hear as the idea of moving the decimal point. Now, decimal points don't actually move, but we can count the gaps between the digits to get from the decimal point to the cutoff point, which gives the impression of the decimal point moving. Well, let's do that. 1, 2. We've counted 2 moves, and that 2 correlates with the 2 here, 10 to the power of 2. So we end up with 2.5 multiplied by 10 to the power of 2. Let's look at the other examples, and then you hopefully might start to see what's going on. 317. So in standard form, we're going to have 3.17 multiplied by 10 to the power of something. We need to work out what that something is. I'm just going to write down 317. Here's our cutoff point, and there's where the decimal point is. We need to count the moves from the decimal point to our cutoff point. 1, 2. And again, we have 3.17 multiplied by 10 to the power of 2. Now, in both of these examples, we can check that the answer is right. 2.5 multiplied by 10 to the power of 2 is 2.5 multiplied by 100, and if you're confident or comfortable with multiplying by 100, you know that 2.5 multiplied by 100 is equal to 250. And similarly, 3.17 multiplied by 10 to the power of 2, or 10 squared, is 3.17 multiplied by 100, which is equal to 317. Let's do 3,900. In standard form, we're going to end up with 3.9 multiplied by 10 to the power of something. Let's work out what that something is. So we have 3,900. There's our cutoff point, and there's where the decimal point is. We now count the moves from the decimal point to our cutoff point, and that's 3. So we can write 3,900 as 3.9 multiplied by 10 to the power of 3. For the next 2 examples, I'm going to do it slightly differently. We're not going to write the number out again. I'm just going to use the number that's already written down. I've got 540,000. So we know that the answer is going to be 5.4 multiplied by 10 to the power of something, and we're going to work out what that something is. So there's our cutoff point, and there's where the decimal point is. And if we count the moves, 1, 2, 3, 4, 5, we know that this power must be 5. So the answer is 5.4 multiplied by 10 to the power of 5. And 504,000, we know it's going to be 5.04 multiplied by 10 to the power of something. There's our cutoff point, and here's where the decimal point is. And if we count the moves from the decimal point to the cutoff point, 1, 2, 3, 4, 5. Therefore, our answer is 5.04 multiplied by 10 to the power of 5. Now let's try the decimal numbers. 0.0035. For this example, I'm going to write the number out again, 0.0035. So we're going to end up with 3.5 multiplied by 10 to the power of something, if we are writing this in standard form. So our cutoff point is here between the 3 and the 5, and here's the decimal point. We now count the moves from the decimal point to the cutoff point. We get 1, 2, 3. So this is 3.5 multiplied by 10 to the power of minus 3, not plus 3. Remember that when we're writing in standard form, we're writing the number as a multiplication of a power of 10. Remember that this 10 to the power of minus 3 means 1 over 10 to the power of 3, or 1 over 1,000. 3.5 multiplied by 10 to the power of minus 3 is 3.5 divided by 1,000. Let's look at the next question, 0.0072. Again, we're going to have the answer 7.2 multiplied by 10 to the power of something. So let's work out what that something is. So I'm just going to write out 0.0072. Here's our cutoff point, and here's the decimal point. We now count the moves from the decimal point to the cutoff point, and we end up with 1, 2, 3. So our answer is 7.2 multiplied by 10 to the power of minus 3. 0.00703 or 703. So we're going to end up with 7.03 multiplied by 10 to the power of something. So here's our cutoff point. Here's our decimal point. And we count the moves from the decimal point to the cutoff point, and we end up with 1, 2, 3. So the answer is going to be 7.03 multiplied by 10 to the power of minus 3. 0.0516. We're going to end up with 5.16 multiplied by 10 to the power of something. And that's something, well, here's the cutoff point and here's the decimal point. We count the number of moves. Well, that's 1, 2. So the answer is 5.16 multiplied by 10 to the power of minus 2. And finally, 0.00049. So we're going to have 4.9 multiplied by 10 to the power of something. So here's our cutoff point, here's our decimal point. We count the number of moves from the decimal point to the cutoff point. 1, 2, 3, 4. So the answer is 4.9 multiplied by 10 to the power of minus 4. So here's some questions for you to try. First of all, write the following numbers in standard form. So if you want to have a go at these questions yourself, pause the video, then when you're ready, press play. But I'm briefly going to go through the answers. So we have 8,950. We're going to end up with 8.95 multiplied by 10 to the power of something. Let's work out what that power is. So the cutoff point is between the 8 and the 9. Here's our decimal point. And if we count the moves, 1, 2, 3, so it's 8.95 multiplied by 10 to the power of 3. 703,000. So we're going to end up with 7.03 multiplied by 10 to the power of something. So we're going to work out the something. Here's our cutoff point. Here's where the decimal point is. We count the moves. 1, 2, 3, 4, 5. So the answer is 7.03 multiplied by 10 to the power of 5. Here we've got 2 million. So the answer is going to be 2 multiplied by 10 to the power of something. Here's our cutoff point. Here's the decimal point. 1, 2, 3, 4, 5, 6. So the answer is 2 multiplied by 10 to the power of 6. Then we have 0.000964. We're going to end up with 9.64 multiplied by 10 to the power of something. And that something, remember, is going to be negative. Here's the cutoff point. Here's where the decimal point is. We count the moves from the decimal point to the cutoff point. 1, 2, 3, 4. So we end up with 9.64 multiplied by 10 to the power of minus 4. 0.00006. So we're going to end up with 6 multiplied by 10 to the power of something. Again, that something is going to be a negative. So there's the cutoff point. There's our decimal point. We count the moves. 1, 2, 3, 4, 5. So we end up with the answer 6 multiplied by 10 to the power of minus 5. And finally, with this set of questions, 0.00307. So we're going to end up with 3.07 multiplied by 10 to the power of minus something. There's our cutoff point. There's the decimal point. We count the moves. 1, 2, 3. So the answer is 3.07 multiplied by 10 to the power of minus 3. And for this set of questions, we're actually working backwards from standard form. Again, pause the video and have a go and press play when you are ready. So 4.6 multiplied by 10 to the power of 5. Remember that 10 to the power of 5 is 100,000. So basically we got the calculation 4.6 multiplied by 100,000. And if you're comfortable with multiplying by powers of 10, you end up with the answer 460,000. And the beauty is you can quickly check this to see if you got the right answer by quickly marking in the cutoff point where the decimal point is, and then counting the move from the decimal point to the cutoff point. 1, 2, 3, 4, 5, and that matches up with the 10 to the power of 5. 9.1 multiplied by 10 to the power of minus 3. So remember that 10 to the power of minus 3 is actually 1 over 10 to the power of 3, or 1 over 1,000. So this standard form of 9.1 multiplied by 10 to the power of minus 3 is the same as 9.1 divided by 1,000, which gives us the answer 0.0091. And again, I can check the answer by putting in the cutoff point, putting in the decimal point, counting the move from the decimal point to the cutoff point, which is 3. And of course, it's minus 3. So I know that the answer's correct. 9.09 multiplied by 10 to the power of 4. So that's going to be 1.09 multiplied by 10,000. And that gives us the answer 10,900. And if we check that, we can see we've got the right answer. 3.05 multiplied by 10 to the power of minus 2. 10 to the power of minus 2 is 1 over 10 to the power of 2, or 1 over 100. Basically, we've got 3.05 divided by 100, which is equal to 0.0305. And here's a quick check. And finally, 7.8 multiplied by 10 to the power of minus 4. So that's 7.8 divided by 10,000. So that gives us the answer 0.00078. And here's a quick check. The point of writing numbers in standard form and understanding standard form is the ability to write large numbers in a simpler way, so that when you see an answer like this, you have an idea of what it is saying. Let's do another example. 312,000 multiplied by 4,700,000. And here's the answer on my smartphone, and here's the answer on my scientific calculator. The answer is 1.4664 multiplied by 10 to the power of 12. And this means that the digit 1 will be in the 10 to the power of 12 column, looking something like this. And if I did 3.06 divided by 18 million, we end up with, on the smartphone, we've actually got 0.00000017. Now, the reason why it did this is because it can cope with the number of places after the decimal point. Now, this isn't necessarily an easy number to read or write. So if we were to write this in standard form, we know it's going to be 1.7 multiplied by 10 to the power of something. And that something is going to be a negative. So here's the cutoff point, and here's the decimal point. We count the move from the decimal point to the cutoff point. 1, 2, 3, 4, 5, 6, 7. So this is 1.7 multiplied by 10 to the power of minus 7. And this answer correlates with what I have on my scientific calculator for the same problem. Anyway, that's all I'm going to be covering on standard form. I hope you found the video helpful. If you did, don't forget to like and subscribe, and thank you for watching.